In this paper, we present a novel framework to synthesize manga backgrounds from real photographs. Traditional Japanese manga is distinctive in its detail and tidy drawing. A labor-intensive task in manga production is the creation of background. Many artists already made use of computer techniques for background drawing, such as halftoning, hatching, and even commercial software. However, they are very inconsistent in style to the artist work on the left. We propose a framework to convert a real photo to style-consistent manga background. We first study how manga artists produce background. Their work usually begins by sketching the structural lines. Then more detailed lines are laid. Finally, screens are overlaid to produce tone, shading, and texture. To mimic this line and screen production, the proposed framework contains two major parts, the line drawing and the screen laying. We first describe the line drawing process. By examining how an artist sketches, we note that long, straight, and structural lines are always bold for emphasis. The important curly lines are usually drawn with varying thickness. Therefore, we propose a model to evaluate the importance of a line. It is determined by 4 factors. According to artists' practices, we give long lines higher importance than shorter ones. We then compute the curliness of a line. A very curly line is given a lower importance. Next, we assume a line associated with a larger region is more likely a structural line. Finally, we form an image pyramid and detect edges on each level. Those lines with a counterpart or parent in higher levels are given higher importance values. We form the line map from the unstructured edge pixels. With our importance model, we compute the importance value for each line. Less important lines are filtered out according to the user control. With the line importance, we then embolden the structural lines, as the manga artists do. We formulate this thickness adjustment procedure as an optimization problem. First, the important lines are thickened homogeneously. Second, according to the local curvature, we produce stylish lines with varying thickness. Note how the thickness varies according to the local curvature. The second procedure in manga production is screening. Manga artists utilize many screens to express shading, texture, and even fine details. In our framework, we propose 2 automatic ways to lay screens for shading and structures. To identify the regions in an image, we form a segment map based on the improved mean shift segmentation. For each screen in the database, feature vector in the Gabor wavelet domain is computed. This feature vector captures both the texture and intensity signals in multiple scales and orientations. A representative feature of each segment is computed. The distance is measured between the feature vectors of the target region and a candidate screen. The screen with minimal distance is selected. Notice how the selected screen matches the target region in intensity as well as texture. Other segments are done similarly until the whole background is screened. In some cases, manga artists may use pre-printed screens to fill the region with statistically periodic patterns, such as the stone wall in the left-hand side image. To simulate this, we perform the same texture analysis on the line map. Next, for each candidate screen in the database, we can compute a distance map from this line map. We then fill a segmented region with the best matching screen. The resultant screening exhibits a tidy instead of irregular pattern. With this approach, users can optionally replace the whole region with the desired screening to express different appearance. Here we show more results. Lighting effect. Fuzzy silhouette tiling. Speed line generation. Style switching. Day and night.